Welcome to the jungle. I'm happy to announce that Kameleo's Docker version is now out of beta stage. It is production ready, works just as well as our Windows and macOS desktop apps, and makes the scaling of undetected browser automation infrastructure much simpler. Let me walk you through it. First, I start the container and verify that the Kameleo Engine is running and ready to accept commands through the local API. Before launching one of our stealth browsers, I expose the dashboard and the VNC viewer through Docker Compose, which makes the rest of the demo much more visual. The dashboard lets us monitor what is happening inside the Kameleo engine, while the VNC viewer lets us interact with the browsers when needed. Both are useful for onboarding and debugging. Once the service is running, the dashboard is available on port 80 of localhost. From here, even without writing any code, I can access thousands of fresh browser fingerprints that help the launch browser to stay undetected. I'm going to run a quick Playwright example, but please note that our browsers are also compatible with Selenium and Puppeteer. First, I install the Kameleo local API client npm package, which simplifies communication with the Kameleo engine. Let's see the example script. It selects a Chrome fingerprint, downloads the matching Chroma kernel into the container to emulate it accurately, then starts the browser profile, navigates to a bot detection page with Playwright, and then takes a screenshot showing that the detection is successfully bypassed. Now let's take a look at the VNC viewer showed at the beginning of the demo. Using the exposed port, I can access the browsers running inside the container directly from my host machine's browser. On the dashboard we saw earlier, I can also see that the newly created browser profile is already up and running. If something goes wrong, the container logs are the first place to check to understand what is happening. For production setups, using named volumes is recommended because it allows Kameleo to persist the downloaded browser kernels between container restarts. This way, Kameleo can reuse the kernels instead of downloading them again, resulting in faster cold starts while still keeping the browser environment fresh and production ready. Now let's look at another powerful capability of Kameleo. With just a few lines of code changed, I can emulate a mobile browser from inside the container. Even based on canvas fingerprinting, the browser is identified as running on a real Android device, which shows that all fingerprint parameters of the launched profile are fully consistent. It also worth mentioning that Kameleo supports two browser engines. When I select a Firefox fingerprint, Kameleo uses Junglefox, our Mozilla-based engine, which can be useful for scaling and gives you more stealth configuration options. Our team continuously works to keep our browsers stealth ready against modern anti-bot systems. We run internal audits of our masking capabilities and publish the results on GitHub, so you can check how Kameleo performs across websites protected by different anti-bot solutions. Still not convinced? Start using Kameleo for free and try it yourself in less than 60 seconds.